Hi, this is our podcast of our NSTA 2013 presentation, How Do You Explain the Explanation? Incorporating Claim Evidence Reasoning, or CER, into your classroom. And if you haven't seen it already, there is a URL at the bottom of this slide that has a bunch of resources, including some of the work we'll talk about today. So we're going to each introduce ourselves and tell you a little bit about who we are and where we teach.
Hi, my name is Tracy Schlamer, and I teach chemistry in Denver, Colorado.
I'm Stephen Traphagen. I teach AP Biology and co-taught Prep Biology in Rolling Meadows, Illinois, and I started my career in Boston, Massachusetts.
And my name is Kirsten Milks. I teach AP Bio and Earth Space Science in Bloomington, Indiana, and I started my career in the Bay Area. When we gave this live, we asked people who they were, and we saw a mix of people who fit themselves into these 5 different categories. So we're going to start by defining an argument in science. The thing we're talking about is an answer to a scientific question that uses data. So that's the scaffold around which we'll build all of our work today. We hope that by the end of this podcast, you'll understand the importance and relevance of argumentation as scientific practice. You'll develop definitions for claim, evidence, and reasoning in scientific argument. And you'll see CER scaffolds as tools for approaching dilemmas in classroom practice. And we definitely learned about perspectives of CER in a way that was really useful. We definitely got some ideas about how we might use CER in classroom, and we definitely got better at using CER ourselves, which is pretty cool. Okay, so we're going to start with an intro to CER as a scaffold for scientific practices. We're then going to give you the opportunity to analyze some student work. We're going to define CER using some examples. Then we're going to share some dilemmas in our classroom practices and CER tools that we use to begin to address those dilemmas. So why argumentation? Well, argumentation as scientific practice is connected to all of the new standards, including the framework and the next generation science standards, the AP Biology framework, and a wide variety of other standards that teachers are working with in schools. It's a way to improve both learning and engagement in science. It provides an opportunity for students to learn from and about argumentation. And it supports students' understandings of the reasons and empirical evidence for the explanations that scientists make in the real world.
So when we start to look at the new standards in science, the next generation science practices and the College Board science practices, we see a lot of commonality. We also included the ACT College Readiness Skills. So looking at these, it initially gets pretty crazy, but we see that the new standards both include this bit about evidence-based argument, and that's where CER comes in.
So what is claim evidence reasoning, or CER? It's a framework that's been worked on by bunches of different really talented people, including McNeil, Sampson, Grooms, and Kraychuk, as well as many others. It's a framework that provides scaffolding for students so that they can successfully participate in the argumentation process. So here's the short story. CER has students make a claim about a problem, provide evidence for that claim, and then provide reasoning for their thinking.
So now I'm going to walk you through the activity that we had our participants do. So our participants were at large round tables with about 8 people per table, and we had 3 different steps to this process. So just to give you a context, we used a sample lab from my chemistry class where we were in the calorimetry unit. We were learning about energy and energy transfer. So we were looking to see, okay, if we compare these 3 different food items you see at the bottom, how many calories of energy were released for every gram of hot fry? How does your experimental evidence of calories per gram compare to the nutrition labels? And then how does the energy per gram of a hot fry compare to the energy per gram of a baked potato chip or a marshmallow according to the nutrition labels? So what we want you to do is pause in just a second. This is a sample conclusion. Each sentence is labeled, and what you are going to do is you're going to take a moment, pause the video, and analyze the student work independently. You're going to circle the claim, underline the evidence, and box the reasoning. On the bottom, you'll see that here's a little reminder as to what our loose definitions are for now. And keep in mind that there's not a right or wrong answer, just go with your gut instinct. So make sure to pause here before continuing.
Cool. If you want to keep looking at this, you should know it's available at that tiny URL from the beginning of the presentation.
Okay, so now, you know what? Find a friend, have them do it. Then come back and share with that friend what were some similarities and differences, and then why did you make the choice that you did? So you can pause here. Okay, hopefully you've shared with a buddy now. And so what we did in the large context to make our thinking visible was within those large tables at the meeting, they were to come to a consensus as to what parts of the paragraph go where. They used sticky notes, and then there are different areas in the room designated for claim and evidence and reasoning. They wrote the sentence number on a sticky note and put it around the room. Just to summarize what we saw was there were some patterns as to where certain sentences would go, but overall it was kind of a decent spread.
Yeah, and we also saw people having a lot of conversations where they had a conversation and were still unsure about where to put the stickies.
Mm-hmm.
Right, so to address this problem, we need to define claim, evidence, and reasoning based on what they do for a student argument. So we want to walk through some of those working definitions at this point. So a claim is something that gives a focus to the argument and answers the question, what is this about, or what is the answer to the question? So the claim focuses what comes next. So evidence is data that we use to support our claim or to answer the question. And one of my students made a point this fall that evidence, in trying to explain this to another student in our class, he said, evidence is anything you can show on a y-axis, which was really useful and tangible. And of course, we're going to go beyond that definition in a little bit. Once we get beyond that one lab activity, things that we've previously learned about science can become evidence. So an example with of this is Erwin Chargaff, who discovered through lots of different experiments, he compiled a bunch of data, and he learned that in DNA, A always binds with T and C always binds with G. When he did that, that was a conclusion based on lots and lots of evidence. Now that we know that, we use that as a piece of evidence to do other things. So things can become evidence as they age. So we're going to address this using the central question, what do you need to show them to make them understand? So evidence answers that. So reasoning then serves to connect different pieces of evidence to each other and to connect the evidence to the claim. Or it can tie the claim and evidence to important science ideas. And this is where science-y vocab words come in, words like evolution or polarity. Reasoning answers the questions, what does the evidence mean, or what else do we know about this? Okay, so to summarize, claim, what is this about? Evidence, what do you need to show to make them understand what this is about? And then reasoning, we need to tie it together. What does the evidence mean, and what else do we know about this? So at this point, we went back, our table groups went back to the work they had done to maybe move stickies from one place to another, resolve some conflict they may have had within their group or between groups, and to validate the work that they had done now that they had these common definitions.
So what we're going to finish up with is a series of questions or dilemmas that you might see in your classroom around CER tools. And just some things that we have learned. We are not the experts. We didn't invent this. But these are just some things that we've found have helped or what we've really learned from. So maybe this is your classroom dilemma. How can I just begin to scaffold argument for myself, my students, my colleagues? Where do I start? So what I did is I didn't reinvent the wheel. How do you assess this in a way that's clear to you and your students? This is just straight from a research paper by McNeil and Kraychek that really does a nice job of, at the top, gives kind of what are those benchmarks based on your level for claim, evidence, and reasoning. And then below, examples of, okay, for that particular learning experience, what would be a sample? So what I did is I took that and edited it for the food lab. So basically, to summarize this technique, the beg, borrowing, and stealing technique, I guess, and taking what's already there, great scaffolding opportunities and really student-friendly, both for your students to maybe peer review each other or for you to really communicate clearly with your students. So for instance, for the complete claim, I gave a sample of, okay, what do you need to have for each piece for all three of those things that you're trying to defend in that lab? And what might that reasoning look like? Because I found for me, it is really difficult to teach my students what reasoning is. And this was at the very, very beginning of teaching my students that year what claim evidence reasoning is all about. So as you see, so this is the same thing that you looked at a few minutes ago. These conclusions are really informative of student ideas. So for instance, this student said, I think the reason that there was more energy released per gram of the potato chip as opposed to the marshmallow is because it was impossible to fully burn the marshmallow because it is really dense. Okay, so sometimes maybe a little bit more than your ego can handle. To give context, this was a really high-performing student in my class, and I was really surprised to see this. And the great thing is that we got to have some really great conversations in class because I saw pretty consistent patterns, maybe not of this idea, but just of general misconceptions, which was really wonderful. Okay, and then one other dilemma that I've really faced was how can I increase the rigor for all of my students? I found that some students really picked this up and really, built it into maybe their mental model of how maybe they learn to write in other contexts. So basically, CER can act kind of as the core to expand upon. So this is from another paper by McNeil and Kraychik. And just really looking at a framework where on that level 1 side highlighted in blue is what we've been talking about so far, how that reasoning really links that evidence to the claim. However, what I did is that, after 2 trimesters of looking at student work in my class, I chose a small subset of kids where I incorporated this rebuttal idea of, well, why is it not this particular counterclaim? So a brief working definition of a rebuttal is I made it an addendum to the core CER response, and it explains why a plausible alternative is not logical within that context. So it is not blank because, or alternatively, blank seems like it would work to support the claim, but it doesn't because. So how can you maybe scaffold this to get started? This is a resource that I actually stumbled upon. We've used it, but we are not selling this, okay? But I kind of figured out by accident that as I used a lot of these formative assessment probes, there are lots of really excellent research-based counter claims that students can write about, and it's been really great to see the growth in that.
So I became really interested in getting my students to write more, and writing lab reports was one thing, but we can't do those as often as I wanted my students to write, and also those are a significant investment of my time to grade and get back to them, and I wanted them to write more than that. So after we started the basic framework of CER, and the kids had done a couple of those, I used CER as a weekly summarizer, so the kids would use their science notebooks and for the evidence and reasoning for the week on whatever topic we had just finished. So for example, and I would give them claims to sort of simplify that piece of the process. We wanted to do this fast, and we wanted to do this often. So the claim, cellular respiration and photosynthesis are very similar processes, differing only in the direction of the reaction. So the student's response to that, their claim is either going to be yes, comma, complete sentence, or no, comma, complete sentence. And then they would support their claim with evidence and reasoning. As we moved through the year, I would give them claims that could be layered a little bit more. So, for example, mitosis and meiosis 1 are very different, but mitosis and meiosis 2 are very similar. Therefore, meiosis 1 must cause all the key differences between sex cells and normal body cells. So you see here there are different opportunities for students to agree or disagree with different pieces of this claim. So there's a little bit of layering here. The important thing that we all want to emphasize at this point is when you start doing CER with your students, the writing you get back is going to be terrible.
Really bad.
Horrible.
And and you need to not quit your job and go hide in a closet. The whole reason we're doing this is because we know student science writing is not what it could be. That's why this protocol was developed, and that was our initial interest in doing it. And so I was very, very discouraged as I started this work, and I was persuaded to keep at it by a very clever person named Mandy Knight, who worked with Kate McNeil at Boston College. And she pointed out that, she asked me the question of why we teach mathematics. And I said that because it's a powerful tool to describe hard things in the world. And she said, don't you think the same thing is true of English? I said, okay. And she also said that this should be an iterative process, that even if you do peer review, and I had tried that, and you have the kids write additional drafts of that first CER is going to be terrible forever. So the thing is to move on to the second CER and the third and the fourth, etc. And through these iterations, they get better at doing this thing. So Linda Darling Hammond talks about a lot of things in education using the metaphor of dribbling a basketball. And most people know how dribbling a basketball works, but that's different than being good at dribbling a basketball. And so rather than being assessed all the time on how many dribbles they get correctly, students need to continue to dribble. And they do it a lot of times without supervision, and occasionally we check in. So I need to be honest at this point, I don't grade all of these weekly CERs. In fact, I don't even grade most of them. The idea that we would limit the amount of writing that our students do based on how much we can grade does two very bad things. One, it sets our sanity as the level of work that we should be doing in our classes, which is a dangerous way to teach. And the other piece is that it artificially limits the amount of practice and work and getting better that our students can do. And we don't want to do either of those things. So better science through not grading. But if I found as we did this and the students iterated, something really special started to happen. So this is the final project that we did in our biology class a couple of years ago. I asked the students to craft a claim that linked together two different units of biology. And in this case, each unit was one of the principles of life as articulated in the BSCS Human Approach textbook. So this student started with the question, what is the effect of evolution on the sequence found in DNA? And he went back through his science notebooks, and from evolution, he found the genetic change over time is due to the changing in the species. Survival attributes aren't changed. The individuals with weaker survival skills die, leaving ones with stronger attributes left to reproduce. And then from his May notebook, he found DNA, which is coded into RNA and coded into protein, which gives these attributes. He took these and together made a claim, if the attributes determine survival and attributes come from DNA, then DNA is the thing that causes evolution, not just the individual surviving. This made me really, really happy because he had essentially invented Richard Dawkins' concept of the selfish gene, one of the seminal ideas in biology in the 20th century. And I know for sure he didn't get this from an outside source because I was standing in front of him as he reasoned his way through this. And when he got to this point and he started saying something, I high-fived 6 people and I said, you need to write this down right now. So the message that this project should send is that though not every student is going to do this, this student never would have been able to do this had he not polished his articulation skills. I went into this CER work with the goal of trying to better find out what the students knew. But what I found out was doing CER allowed them to learn more stuff.
Cool. So in the last couple of minutes, I'm going to share with you a couple tools that might be useful and that might speak to you for where you are in your classroom dilemmas. Stephen is totally right. Formative assessment has been shown to be really helpful, and all this practice is shown to be helpful too. But like Stephen said, I just can't read all these and give as much specific feedback as students might need. And so then I had this idea that peer feedback would let them get lots more help than I could provide. But like every single classroom that any of us teach, I had this wide array of people with a wide array of backgrounds and language skills. And so the puzzle for me was thinking about how students might use each other as resources, even if their argument skills are really different places. And so this is something that I've modified from work that was published in the Science Teacher in 2010 by Sampson and Grooms. And these are criteria for successful arguments. I know they're really small. I'll show you big headings in a second. But this is a check sheet for yes, maybe, no, with space to write for each of these sorts of headings. So you can see the headings generalized are on the right-hand side. Counter evidence is gray for me because in a really excellent argument, everything will be checked yes, except for this thing, counter evidence, which will be checked no. So that's why that's grayed out. What I really like about this sheet is that students can give each other feedback on spoken or written explanations. They can choose to write some notes. I can ask them to write some notes for where they're assessing. There's this maybe category, so if students aren't sure, they don't feel locked into yes or no. And depending on what I'm after, I can look at different things. I can look at none of these. I can look at all of them. I can pick one student over 3 days. And so depending on what my goals are for my students at that time, you can use these criteria in a lot of different ways. So here's one more tool that we've really found useful. It's from BSCS. If you use it, you must include the copyright and attribution at the bottom. And again, this is found on the website along with all these other tools that we've been showing you. So this tool starts with students asking a question, the question that their work is trying to answer. After that, they put evidence and reasoning into this table format. And so early in the year, your learning goal for your students for this activity might be that they have selected data to use as evidence and that they have listed it in ways that are appropriate on the left-hand side. Later on, you might want to check reasoning to make sure that it says everything it needs to say. Still later on, you might decide that you want students to link up evidence and reasoning logically so that the whole row across makes sense together. So you can use this tool in a lot of different ways depending on what you want your students to practice. After that, students write a full and complete claim. And that ordering means that students are going to write more successful and more thorough claims. And also, according to BSCS, this mimics the more authentic nature of scientific practice that scientists in everyday world do, that they are collecting data and thinking about reasoning and then coming to a more formal claim from the claim that they maybe had first made when they unwrapped their plates or looked at their computer results. Finally, at the bottom, students pull all of this stuff together in one final paragraph form. And sometimes that's the only thing I assess. By now, I don't usually give students this form. We're pretty late in the school year. So I'm not even using this structure anymore. I show it to remind them of this idea and all the things we've worked on.
So hopefully this has been useful to you. Our thinking in sort of designing this, and certainly our use of stories, comes from a lot of the really good PD and presentations that we've gone to. I know I've come away with this idea that here's this great tool I want to use in my classroom, and then here is the implementation of it. And it's sort of a dogmatic way of I need to do what the presenter did. What we're hoping this did for you was to give you sort of a broad definition of CER as an idea, and then somewhere in our stories, hopefully something caught your attention and got you thinking about how you might use it in your classroom, even if that use isn't anything that appeared in our presentation. So thank you very much for your attention. We need to thank some people.
So first off, Michelle Cheney, who is a teacher developer at Knowles Science Teaching Foundation. The three of us work in very different places, but we know each other because we're both teaching. All three of us are teaching fellows through this organization. And Michelle's been really helpful in furthering the cause and discussion of scientific argument in that community. And she contributed a lot of work to this presentation and a lot of the planning that let us make it. Really grateful to NSTA for having us. Stephen and I are both members of the AP Biology Leadership Academy, and so we're really grateful to BSCS and to NABT. We gave a previous version of this talk at NABT in fall of 2012. And last but not least, Kate McNeil at Boston College and other people who have worked on this really intriguing framework for helping students. One more time, if you'd like to see any of the tools that we used, they are available at that tiny URL at the bottom of the page. Thank you.
Thanks.
Bye.